Good morning, I am Arturo Lobo, responsible of Solar project, which has been carried out by a small group of engineers and architects to develop the solar heating system with generation of changing aesthetics. This project has received a Research and Development Award, and it has been currently 2 worldwide patents pending. At the whole group of videos we want to present you the main patent in detail, and also the descriptions about some products and several aspects related with this technology, whose aim is illuminate with sunlight a house or a building or absorbing that energy according to the thermal demand curve, and without mobile elements. It means that the system absorbs much more energy in winter than in summer, and that is necessary to be able to dimension a solar heating system which in winter needs 8 times more energy than domestic hot water, that ACS curve, and nothing in summer. In addition, that technology allows generate picture or colors on the building's facade, without mobile elements. This image or colors could change with the sun or spectator position. As well, the system is able to generate high concentrations. To understand the system, it is recommended to start by the videos of summary and basics. We apologize you for the simplicity of these videos which has been created by the research team itself, only with educational and informative intention. This introduction, with a length of 1 minute and a half, is repeated in all the videos. Apart from the main patent, there is another one that complements it. It is relative to solutions using vacuum tubes and gathers new products based on them. In a short way, a vacuum tube is composed of 2 concentrated glass tubes. In the space between both of them, the vacuum tube is found. Therefore, the heat transmission from the internal tube towards the exterior one is very low. Generally, the vacuum tubes are used to collect the solar energy that reaches the absorbent coating of the internal tube. The absorbed heat is transferred to a heat pipe which is located inside the tube. This may also be done to a U-pipe at the U-pipe system. Tubes are placed in a way that they form panels. These panels gather the collect heat through each tube and through its pipes. The focus of this patent is completely different. It uses vacuum tubes with enclosing functions, while partially sacrificing its efficiency as a collector. Basically, the patent claims to build an enclosure wall with vacuum tubes that is possible by touching each tube with the next one. The gasket has to guarantee the correct insulation between the internal side of the tubes and the outside. If the gasket is made with an insulating material and the design is appropriate, the thermal conductivity of the wall could be around 1 Watt square meter Kelvin degree, that is similar to the thermal conductivity of another conventional walls. The heat transmission between the outside face and the inside face of the wall is mainly done through the external tube walls. That means that it is due to the linear conductivity of the external tube wall. It is shown in this picture, which has been calculated by finite elements. These results improve with a bigger diameter of tubes, and the thermal conductivity of this enclosure could reach values of 0.8 watts square meter Kelvin degree. If the tubes are transparent, it would allow the passage of most of the light, but with a slightly distorted image, which provides privacy between the inside and the outside of the wall. If the gasket surfaces are reflexive, these effects are accentuated. On the other hand, the main patent claims a technology to harvest solar energy in accordance with the seasonal thermal demand curve of the house or building, and without moving parts. The geometry is optimized as well as all the design parameters for the hole. These hole forms are small linear concentrators and its absorbing area, both of them which are fixed. For that optimization, the absorbing area receives much more energy in winter than in summer. This is according with each season of the year, and for each given geographical location. During the largest part of the day in summer, the sun is high. When this happens, the concentrator reflects the incidental light into the sky. This contributes to refresh the building, the environment, and the planet. In spring, autumn, and partially in summer, the sun is not so high. In this case, the incidental light reaches the zone that is close to the absorbing area, but the incidental light does not touch the absorbing area. Due to this, the system does not collect much energy at this time. When the solar heat is typical of winter, the concentrated radiation falls on the collection area most of the time. Therefore, this area collects a lot of energy over the course of the day. At first hours in the morning, the reflected radiation reaches the nearest zones to the absorbing area that is located at the internal side, but the radiation does not reach directly the absorbing area. Because of this, the energy is barely collected. That is least certain if the captation area is a vacuum tube, because they have a very low heat loss coefficient, and the vacuum tube could be placed at the black, yellow or pink zone if it's necessary. The optimization for each locality or wall orientation determines how large has to be the absorbing area, within standardized values, to collect in accordance with the seasonal thermal demand curve. Most of the solutions of the main patent can be particularized using vacuum tubes. For example, in this picture, the concentrator with its absorbing area is into a transparent vacuum tube. A heat pipe, that could be a U-pipe, is in touch with the metal sheet and that forms the absorbing area. If the design is according to the patent, then the harvest energy is similar to the demand energy for each season of the year. This solves the above problems of sizing and heating system regarding one of hot water. Even if the vacuum tubes were conventional, with an absorbent coating on the surface of the inner tube, this configuration of panel with adjacent tubes separated by gaskets that we name vacuum tube wall still keeps the hermetic and insulation properties between the inside and the outside of the vacuum tube's wall. Even a certain amount of sunlight passes through this vacuum tube wall. Normally, the radiation reflected at the concentrator is used to heat the absorbing area. However, the main patent contemplates another possibility. This alternative is allowing the light to pass through the harvesting area, so that it reaches a reflexive surface, which is optimized in order to redirect the light towards the internal side of the panel. That solution is also applicable to vacuum tubes, improving insulation properties and keeping the hermetic properties. That configuration could be simplified even more building the vacuum tube wall, where the vacuum tube wall are separated from their adjacent tubes by a gasket which already we incorporate a reflexive surface, that is the concentrator, and another one which is a concave reflexive surface. The gasket number 5 includes the concentrator reflexive zones, number 6, and the concave reflexive surface number 2. This reflexive surface could be placed into the internal tube, line number 1. But this solution is more expensive. On the other hand, the gasket could adopt other equivalent forms, such as the number 4, but a concave reflexive surface should be created at the external tube, line number 3, which is also more expensive. When the sun is low, a part of the sunlight directly goes through by the tubes, and the other part is reflected at the concentrator number 6. Then the reflected sunlight reaches the concave reflective surface number 2, entering in this way at the internal side of the vacuum tube's wall. If the surface and the geometry are alike are described at the main patent, the amount of sunlight that come into the tube at the different seasons will have a form such as the thermal demand curve. An important part of the radiation is absorbed by the vacuum tubes during their multiple crossing through them. But in the patent, several forms are also included to extract part of this absorbed energy. Moreover, on several geographic zones, such as on the north of Europe and high latitudes, it is more important letting the sunlight pass into the building than collect energy. And this vacuum tube walls allows maximizing the sunlight that goes into the winter, in relation to the ones which goes into the summer. That keeps really low the thermal conductivity, which can reach values as 0.8 watts square meter Kelvin degree or less, depending on the gasket length. In addition, this wall can have a front glass and a rear one. In this way, it's gotten an absolute cleanliness and increase of the structural resistance and the thermal conductivity, which can achieve values around 0.5 watts square meter Kelvin degree. The cost of a configuration like the previous would mainly depend on the producer country, but it can be lower than 60 euros per square meter, even lower than some kind of traditional walls, with the advantage that they allow to pass 40–50% of sunlight in winter. With a simple gasket that does not incorporate the concentrator and the concave reflective area, which is very appropriate for north orientation, the cost could be reduced more than 15%. The frame's design allows changing the tubes individually in case of break, and also blow the internal tube to recover the part of energy absorbed by the tubes. Conceptually, the frame is formed by two guides of profiles, where the tubes ends, they shift feet and they keep joined the tubes and the gaskets, even when the gaskets are not adhesive. If these guides or profiles are not straight and flats, the surface formed by the tubes will not be either. It could be done, for example, a circular ledge window, or being the handrail or the enclosure of a spiral stairs, if the guide follows its form. The mostly part of design or configurations of the patent technology are improvable using vacuum tubes. This encompasses all or part of the set of concentration absorbing surface, and in addition, they stay adjacent and with intermediate gaskets doing that enclosure and insulation functions. The patent gathers a lot of different designs, as for example introducing rotatory vertical slats inside the vacuum tube's wall. Moreover, in the configurations where harvest energy from inner tubes is not intended, is avoided the need this inner tube and can be a single tube. This decreases the cost of vacuum tubes by almost half and generally improves the results. For example, if the vacuum tube is composed by vacuum tube with the outer tube and it's placed between two glasses, the thermal conductivity is the same, around 0.5 watts meter Kelvin degree, and the transparency, image sharpness, performance in the pass of the light and energy are higher. And something similar may be the use of vacuum tubes to create high thermal insulation skylights. The video 9 and the next ones show the prototypes and explain how to get benefit on the project. Those benefits could be gotten at individual level or for a company, as well as economic, social and environmental benefits. If you want to produce or you are interested client, we give you more details and free drawings. The project has a social and supportive component. Watch the videos about how to work, to collaborate, to translate, and so on, and help us to spread them. Click to see the other videos or to go into detail on this one.